Hello, everyone. So I work in the company named JetBrains, but sorry if you came here for learning a lot in details about our tools. I'm not going to do that. I'm going to talk about the tools in general. We'll be mentioning our tools for sure because they are luckily the part of the ecosystem. But if you would like to learn in details, come on Wednesday and Thursday to our booth and just ask whatever questions you have. So I work for the company named JetBrains. Previously, for 8 years, I was doing C++ development in the embedded networking area. And then I moved to JetBrains, working mostly as product marketing manager and doing some evangelism around the tools. And so I'm here to talk about the tools. Yesterday, I talked about the view on the language from the point of view of the tools. And this will be a little bit connected, but I will be referencing the talk a little bit. So I was planning to start with a quote. Actually, that's a quote from Björn. It's a little bit scary starting with this quote since Björn is sitting over there. But still, thank you, Björn, for this quote. I have one slide done because of you. Thank you. This is a very famous quote about C++. I hope you all at least heard about it. The story is that on his own side, Björn is trying to explain that this is actually true for all powerful languages. But I must say that from my experience, that is the most true for C++. Because I was interacting a little bit with iOS development, and the stories there are completely different if we talk about the code qualities and the tools. Because they have Apple behind them, they have a lot of standards de facto, they have a lot of tools provided by Apple, and that actually makes their life much easier. So I would like to tell you a small story here. I was working for a company, a very big network operator, who was doing first time in Russia LTE and FreeMax provider. So we were doing very cool stuff, and we were doing it in C++. But to be honest, each time someone was leaving the team, the developer, we were completely and aggressively throwing away all code of this person and rewriting it from scratch. Why? Because we could not maintain it properly. We had a very small team. Each person was responsible for one particular area, so we were not passing the bus test at all. And so that was the reason. And from my point of view, that was bad. That should not happen. But that was life. And I guess we all have such stories in our past. I have another story. That's actually a story about Apple and their iOS update. How often do you read the release notes? Sometimes we do, and sometimes we could find a very interesting thing there. Once they issued an update, and you can find this little line there, impact. An attacker with a privileged network position may capture or modify data in sessions protected by SSL. Wow, that's a huge breach. How did that ever happen? Luckily, the code was open sourced. And so through the history, we managed to, the whole community managed to find the reason. That was this double go to fail line. There was a huge speculation in the community how the error managed to get into the code base. They were huge discussion that were blaming old style go-to statements and talking about changing the error handling idiom to something more reasonable. There were talks about just switch on your compiler warnings, get the warning that the code unused. But who actually gets the compiler warning turned on when they are turned off by default? Really, we mostly skip that when we have deadlines, big projects, whatever. There were some more speculations on proper indenting or whatever. So actually the tools could capture this problem in many, many ways, and we could find it and we could eliminate it. But still the story was that we got the problem. They got it fixed, everything is fine, but still we have now the very famous thing called call to fail. Another example here is we got used to think about C++ about the language where we always have types. But do we always for now? And the example shows that actually no, because to get the type of the operator variable, operation variable here, you actually have to calculate what's going on there. So what's the actual usage? So here it's float. If I use do operation from and pass the integer there, it will be integer. So it actually depends on the usage. And that means that the code in C++ getting more complicated in terms of reading the code. And actually, the problem is that we're getting more mathematical and functional concepts, and it sometimes makes it even easier for us to make a mistake. But we have some things that are here for ages with us, and that actually makes us provide a huge field for mistake. This is an example that shows that to understand what is written in the last line of this test function, you actually have to know the value of the magic macro. Because depending on the magic macro, x is either type or an integer. So it's either a type or not, depending on what is provided somewhere, maybe in the header file or deep in the hierarchy, with some magic context variable, some magic context macro value. And that means that the code in this line completely depends on this thing happening somewhere in the library or whatever. And that's a huge room for making a bad code, actually. So what I'm going to talk here is which tools do we have in the ecosystem that help us to provide C++ of better quality. Some of them are new, some of them are old, some of them are just appeared, or some of them are with us for ages, and some we're still lacking. Let's try to overview and to find out what we're lacking and what we have. But before we do that, let's first talk about what's the code quality. If we're gonna talk about the tools for the code quality, let's find out what the code quality actually is. There are lots of definitions for the code quality, and these are maybe two very famous. This is just the collection of words. The code should be easy to read, actually, because you need to maintain. If you need to maintain it, if you need to support it, you have to read it to some extent. It should be easy to use and should actually work. That would be good enough. Here, if we talk about the efficiency, for example, this, there is IT Software Quality Consortium that issued the right definition on the slide. And efficiency in their definition could be whatever, it could be performance, it could be human resources, so efficient in terms of human resources for all these tasks. But I personally prefer another definition for a code quality. And I guess this is it. This is the code quality. Originally, that was the picture about the code review, but it's not only about the code review. It's about everything. It's about using your code. It's about testing your code. It's about maintaining your code, moving it to the production, deploying it, whatever. The code quality just measures by this number. Okay, let's guess that for now we have a definition for the code quality. Now let's talk about tools. I will again reference Björn here. So in 2015, when introducing the C++ core guidelines, he talked about tools. And I guess that for the code quality, the tools are essential. We can't do anything with the code quality without the tools, because we could keep a lot of guidelines in mind. We can do whatever until we have our deadlines back yesterday. The huge team, something happening, our manager is just jumping around us. And at that very moment, either a tool is throwing something in our face to protect us from the bad code, or we just completely forget about it. So talking about the tools, I will go through these 5 categories. So I strongly believe that for the code quality, the people sometimes think about the code quality as about the code analysis tools, but that's more. So I will talk about the code style and code formatter. I will talk about code generation, code analysis for sure will be here in this talk, refactoring, and unit tests. And I have some bonus in the end. Let's start with the code style. Code formatting. What's the problem in C++ for the code formatting? Let's look at this example. Test function with 2 lines in the end, A and B. And what's actually the problem with formatting this code? Like, these 2 lines in the end of the test function, are they something similar or are they different? If you look for a while, you can find that one is a C-style cast and one is just an expression. And that means actually that you have to format them differently in many cases. Like, that's a very common style. Like, when you have a cast, you have this kind of space before the value you're casting, and if you have an expression, you have all the spaces. A very common style. But to format in this way, what does it mean for C++? You need to parse the code. I hope you're starting getting the idea. So, to format the code, you can't just like read it as text. You have to parse it, and that's actually the thing that is very much different for C++. Like, there are a lot of languages which you don't need to do a full parsing for just formatting the code. If we talk about the formatting, actually there are more things that are making it tough. And like, because we have a very long story with C++ here that's existing for many years, we have a variety of standards existing. Like, there are like Google code style, there is LLVM, LLDB code style, GNU, Qt, like Chromium, whatever. There is also some custom code styles that exist nearly in every company that is doing development in C++. And the problem is that sometimes the styles are different in essence. I mean, not that this is just the different set of parameters, like how to set spaces or indents. Sometimes they're just about completely different things. Some are talking about the name conversion, some are talking about spaces or braces. So you couldn't easily convert them because they're talking about different things. Okay, so this is the reality of the formatting for C++. Next question. When to reformat the code? Actually, there are lots of ways to go. You can format on file saving. You can format on the fly while you're typing the code on your laptop or your computer. You can do a pre-commit hook, a very popular thing. And you can use some kind of an explicit action, like select some piece of code and like call it some kind of formatting. Like, external tools, they're usually doing this kind of file on save formatting or explicit actions, or you can put them on pre-commit hooks. IDEs are mostly about on-the-fly formatting, and there is actually good and bad point for IDEs in that sense, because good point is that IDEs are mostly having the result of the parser, and so they could format using this parsing result. The bad point is that quite often they have to deal with the incorrect code, and you don't want your screen blinking completely while you're typing just because the reformatting is happening on the fly, so they have to wait at least to some expression ends and then reformat or do some more stuff like that. Okay, if we talk about the formatting tools, I guess everyone here is aware about the Clang format. That's nearly the kind of a standard that we have for now in C++. That's the Clang family tool. And it's actually a command line tool, quite easy to use. So you could do many good stuff with that. So you could put these kind of commands like Clang format off on, like to tell it that please don't reformat this piece of code. There's a very good thing about Clang format that I really love is that it has this kind of library profiles. So what's the problem with reformatting the whole project with all the libraries included? You don't want actually the libraries to be reformatted in different styles because they could be written in different style, different from what you use on your project. Clang format actually allows to put different profiles into different directories, and you could just like, even some like good library developers, they provide their file for a Clang format along with the library itself in any kind of Git or other repository. That's actually great, and Clang format is integrated in many tools for now. So like the basic things like there is a Vim integration that provide you with a shortcut, and you could select a region, and the Clang format integration then will do very smart stuff. It will find the next bigger syntactic entity that it actually could reformat and reformat it, or it could do some kind of safe hooks formatting. There is integration in Emacs also that provides the shortcut to reformat the line or any kind of a selected region. There is VS Code integration for reformatting on safe and even type. And there is a ReSharper C++ integration. It's different from others because the guys are just converting the settings to their own formatter tool and then just formatting with their own formatter tool, but with the settings from the Clang format. I know the guys from NetBeans working on some Clang format integration and doing some bow formatter like Clang format when you call it explicitly, and their own formatter with porting the settings when you are typing. But you see, these are like good things in green, but there is one thing in red with Clang format. The Clang format, while it's a part of the Clang family, it's not using a proper Clang parser. It's using a fuzzy parser. And that's reasonable, actually, because they are there for performance of the formatting. They don't want you to wait for ages until the code is reformatted. So they're using a fuzzy parser, and the problem with this parser is that it actually doesn't go into header files, so you could confuse this parser actually quite easily. But like that's the solution they taken, like to provide something quick, but that could be actually confused. So, but you should like know and be ready for that. Like as I said, IDEs, on the contrary, they're usually doing this kind of a built-in formatter tool that is working on the fly, just formatting the code while you're typing. And usually the biggest issues for all IDEs are this kind of an import-export converting issues of different styles, exactly because they're all about different things. So the IDE should like provide the whole set and should know how to convert all the settings properly. Talking about formatter, I would like to mention one project that we actually did in JetBrains for Hackathon in 2015. That's not a production solution. I hope it could be, but still, like, that was a task that the guys just coded at Hackathon. The idea was to extract the style from the actual code formatted with some settings. So you took the code, formatted with some rules, and you run some algorithm that just extracting the settings and get some kind of a setting list that more or less describe this code style. There was a genetic algorithm working there, so with some fitness function that was the modified function of lexical distance between texts and some optimizations to make it work quickly. The good output was that this algorithm actually helped us to extract Google and GNU styles and to use them in C-line as a predefined styles. So we made some kind of a proof of concept. And I really hope we could make this kind of a tool working for everyone, because that's really cool. Like you could just feed some kind of a text formatted properly to this tool and get a style out of it. Talking about the code generation, let's first think about why to generate the code. Actually quite simple, because the code generation is the way to easily keep to some kind of a guidelines, just to force them on you, just to make the code to be auto-generated. So to force some common patterns and to avoid some typical errors that could be there. You could generate actually lots of things. You could generate file templates, at least some kind of a comment in the beginning of the file that's describing that this file was created by some person for some project, whatever. There could be some comments, for example, Doxygen style stubs that you could generate for functions and then fill with proper information and then get the whole documentation for your project generated with Doxygen. There are lots of different code snippets that you could generate, like for constructors, destructors, function, implementation stubs, override, whatever. So if we talk about the IDEs, they have lots of things that they usually allow to generate. Like, I guess every IDE for now has some kind of a code snippets that you could use, and you can actually add your own. And that's great because you can add some patterns that are typical to your project and your company. The example here, this very long piece of code, but actually only the class, human, and free fields in the beginning were actually typed by hand. And all the constructors and all the operators were actually generated automatically by the tool. And that's actually the good thing. So you could just generate all this piece of code, quite a long one, and actually just get it into like 5 or 10 seconds. And you can provide some interesting settings, like how to generate it, for example, if to use std type for a comparison operator or not. So talking about code generation, there are actually some more specialized tools that are there for some specific tasks, like Protabooth, that actually is some kind of an extensible way to serialize data and provide getters and setters to take care of writing and reading operation, like hiding some implementation details from you. There is some transformation tools like Coq that some people are still using. And there are, of course, Clang-based tools. And I'm actually surprised that I don't see a lot from them now on the market, because the Clang, if it could provide you an AST, then it's quite easy to generate from this AST whatever you need. And if we're talking about generation from AST, I couldn't just mention the meta classes here, because that's exactly the code generation. That's exactly the thing that helps us to avoid boilerplate code and to keep to some conversions, to force these conversions on us, and to get like some more types and more flexibility. And this is just the example from the Herb's proposal for the interface shape that is on the top right corner, and then the code for the meta class itself, and then the what we are getting in the end out of the compiler in the bottom right corner of the slide. So, but what does it mean actually? Like for the tools, like this is the code generation, but to implement it, we'll have to first of all get reflection and compile time programming in the standard. Hopefully we could get it in some reasonable time, and then we could get this kind of code generation. The tools could support us. So we'll see. That's actually some kind of a bright future for the code generation that I see. That's a huge step forward in comparison to what we have now, like just generating some getters or setters or some implementing some functions. Okay, that was about the code generation. Now let's talk about the code analysis. So talking about the code analysis, there are actually two big groups. There is static code analysis, there is dynamic code analysis. And talking about static code analysis, there are actually also two big groups inside. There are just compiler warnings, and there are extra checks that the compiler can do. Let's see what tools we have for now, at least some of them. So we have the Clang analyzer. That's a very powerful tool. That's just a part of the Clang, and that's actually great. So you can just run your Clang compiler with some minus analyze option and provide some checks that you would like to be checked on your code. And there are actually about 40 checks available. There are some core checks, there are some like new delete leaks, there are some data code, nullability, and security checks, like for example, using float as a counter in a loop. And this is actually cool, like the core checks, they include something like division by zero or null dereference checks. So there is some kind of basic checks that you could run on your project. And that's not only in Clang Analyzer, there's also another tool in the Clang family that you probably are aware about is the Clang Tidy. And Clang Tidy actually could be called with the analyze option, and the Clang Analyzer will be called from the Clang Tidy, and all the checks will be there. But Clang Tidy is much more. It's actually more than 200 checks on board. I'm especially mentioning the modernized checks here because this is really cool. Like this is how to make your code more modern, how to force you to use the new features. And that's actually what the tools are here for, forcing you to use new language features while you're a little bit staying apart from them and saying, okay, I will wait for others. But the tools say, no, please do. please replace std bind with lambda, please use author in some proper places, please replace C standard library headers with their C++ alternatives, whatever. So I will try to run this short demo. So that's just the Clang tidy working on this piece of code and just checking and adding their fixes to this code. So this is just the integration from our tools, but just to show you how it looks, just not to run from the command line, but you can run Clang tidy with -fix option from the command line and get the same result. But again, so like Clang tidy is much more than modernized. So Clang Analyzer, it has started some work in the direction of the C++ core guidelines. There are not that many, I guess around 16 for now, but still they are like evolving and moving forward. There are some Google checks there, so you could actually, and the good thing is that you could add your own checks. So like imagine you have something specific to your project. So who is checking that? So like no tool, no general market tool is doing some check specific for your project, but you can just add your check to Clang tidy. It's quite easy to implement one, and then just get it work with the Clang tidy and all the rest of the profiles that you have in Clang tidy. Talking about the code analysis, of course, I have to mention the core guidelines. So as I said, for now, if we talk about the tool support, so the Clang tidy actually got around 16 checks on board from the C++ core guidelines. Of course, that's just a very little part of the code guidelines, but still. So most of the tools on the market currently, there are actually two ways. You either use the Clang tidy integration, and then you get the C++ core guidelines through the Clang tidy. That's the way taken by Eclipse, CLine, and NetBeans. Or you do a native support for C++ core guidelines like CppCon core checks in Visual Studio. And I know that cdevelop has their own implementation for some C++ core guideline checks as well. So more or less, we're moving forward to getting these core guidelines checks on board of our tools, so to make it actually work. There is one more tool on the market that I have to mention here specifically. That's the CppCheck. That's quite an old one, you could say, so like it exists for 10 years already, but still, the latest release was in July this year, so it's still evolving. It has approximately 170 checks, and they cover pretty much a good list of things like check variable scope, out-of-bounds checks, some exception safety, some memory leaks, some mismatch in allocation, deallocation things, some size of arguments checks so that you're not providing something negative there or something more than a type, and some others. So, and the good thing about CppCheck is that since it exists for ages, like 10 years, it's quite old period, it gets lots of plugins for various IDEs, like there is a plugin for Eclipse, Visual Studio, Qt Creator, CLine. So, and it's still evolving, so quite a nice tool. Maybe not checking that many, especially for the modern C++, but still can do some general checks for you. There is also a tool called Qwerty that is used by many people here, I guess, but mostly because it's a very good tool for some bigger companies because they have a very good integration with the CI, so with the continuous integration. So, and I know that some people even use the Qwerty in the way that they just somewhere the checks are running and they just got the output, so they do not interact with the tool at all. They just got the result and like see what they got in the end. So it's not that many checks, approximately 18, but some like also some basic coverage for C++ is there. There are actually much more. So there's a PVS Studio that's doing lots of checks for C++. That's a pay tool. There's Infer from Facebook that seems to me very interesting because they got this idea of formal verification behind the tool. That's some kind of different from the general static analysis tools. And they actually have that tool built into the code review system, and that's something that we really like because we do the same for our app source tool for Java and PHP, like we're running the code analysis in the code review tool so that the code reviewer could benefit from the code analysis as well, could see the results of the code analysis in the code review tool. And there are actually lots of other things, like I guess all the big IDEs now have some kind of a code analysis implemented on their own engine. Like, I mean, the NetBeans has, there is Kotlin engine in Eclipse, there is Clang actually doing this job in Xcode. And in C-Line, we also have this thing that is called data flow analysis that I would like to specifically mention here, because I guess it's very cool. It actually checks how the data flows through your program and try to make a guess if something might be wrong there. That's not the thing that the compiler could check, because that's some kind of a runtime check, but it's done as a static analysis tool, like it's done inside the static analysis engine in the tool. So like in these two examples, it's showing some condition is always true or unreachable Q example. So data flow analysis could be actually quite difficult in C++, so like finding these kind of things, going through all possible paths, but still if you run it in the background and once you can get some reasonable result, then cool, you just win with catching some possible bugs. Okay, that was about static analysis. Now let's talk about the dynamic code analysis. Actually, there are lots of tools we have. I would like to mention two big groups here. One is Valgrind and one is Sanitizer. And the reason I'm mentioning these two groups is because they are completely different. The idea of the Valgrind is that it's running just your code on a kind of a virtual machine. So it doesn't require the recompilation. It doesn't matter which kind of a compiler you were using to compile the executable, and even which language you were using, whatever architecture you were using. So it just provides a kind of a virtual machine to run this code with it. That means some problems, of course, because that means that the slowdown will be huge, from 20 to 50 times. And actually, Valgrind is also running one thread at a time, which also makes the process quite slow. But it can detect very interesting things like an initialized memory and other things that I'm gonna talk further. Sanitizers are different. They require the recompilation. But once you've done that, you actually could just run your executable in a usual way and then get some information after that. And that actually means that the slowdown is much less, so it's from 2 to 5 times. But it requires some particular compilers, so sanitizers appeared in Clang first and then in GCC later, so there was some delay with appearing in GCC, and it has some limitations for architectures. And unfortunately, none of these tools are working in Windows. So there are some tools for Windows, some separate tools, but I'm not going to actually cover them. So talking about the Valgrind, this I already covered, so I will jump to the next thing. So the first thing that they come into the people's mind when they think about the Valgrind is actually the memory check. Like when they ask for the Valgrind, quite often they just want a memory check. So just a tool that will find out some illegal read, writes, and freeze operation, some initialized values or some derived from initialized values, some overlapping of source and destination in various memcpy and other functions, which could be critical, and some other checks. So, and the memcheck is exactly the tool for that. So it provides the output in the way like that on the slide. But the Valgrind is much more than the memory check, and that is really cool about the tool, because it has the cache crane, that is a cache profiler. It has some accuracy points, actually, because that's a simulation that's not taking into consideration any kind of shadowing done by the operation system or any kind of external process or kernel or whatever, but still you could get some general understanding from the output. And it comes and very often used with a tool called callgrind. That's also a part of a Valgrind. And that the tool that actually recalls the history of the calls of all in your program. And there is then this CppCon tool that's some kind of a nice viewing tool for the output from the callgrind. And you can just look how it was going there and what happens. It has some problems with the recursive calls. So, and by default, it just provides some information like cycle there. And you could put some additional settings to skip some function calls or just distinguish the recursion level and stop at some point to make it work. But still, there is actually more inside the Valgrind. So there is the Valgrind, the massive, and the Valgrind is the tool for thread error detection actually. So it's catching the things like the misuse of the POSIX thread API or inconsistent lock order or some data races. So you see there is like, that's not only about the memory checks, that's actually much more. So talking about the sanitizers, I'm not sure, maybe that's the only thing that is still keeping Google and Apple together because that's the Google code, but it's implemented in the LLVM. And so the sanitizers are actually supported in Clang from quite an old version from 3.1, and some sanitizers started with 3.2. And in GCC they appeared starting from 4.8. So if you use some old compiler, like, sorry, you're not aware, you can't use just sanitizers with the old compiler. But like if you use some versions like that, you're fine. So there are lots of nice stuff there as well. So there's a basic thing like address sanitizer. You just recompile your program with -f sanitize address and start catching these kind of things like out of bound access or use out of free return or use out of scope and some double freeze errors and all couple of like all variety of things that you could, crazy things that you could do with memory in C++ program. Like this is just example of an output. So also you are provided with a stack tray, so all the information about the address. So very similar to what actually Valgrind does in that sense. There is a thread sanitizer, that's a data race detector. So actually it can actually cause some very good data race issues, and like the two threads access the same variable concurrently and one is right, and so that's an easy way to catch these kind of problems. There is memory sanitizer. The memory sanitizer is supported only on Linux, and I'm not sure about the GCC. I think there's still no GCC support for memory sanitizer. The thing that I really like about the sanitizers when I first heard about it is the undefined behavior sanitizer. Like C++ in some kind of unsafe language in strong sense, because like the compiler allows you this kind of undefined behavior to make the job easier. But it's like the undefined behavior means you know nothing about your program running in the runtime. And so have some tool that is available of catching some at least general undefined behavior cases is actually very good. Sanitizers also provide some API for data flow analysis and some coverage API. So that's not the tool that just running and providing you the output, that's just the API that you could use to build your own tool with that. So that's about the dynamic analysis. There are also these kind of gprof and gperf tools and others, but they're just falling into one or another group, like either running on a virtual machine or just recompilation of the program. Okay, let's move forward. Let's move to refactoring. So I would divide it into two sets. Like there is a basic set of refactorings that we all expect from at least all the tools that are working with the language for us. That's some kind of rename, extract function, and inline. And there are some more profound refactorings that actually could be done, some kind of a change signature or extract whatever you need, like constant or parameter, or pull and push members through the hierarchy of classes, and maybe some modernized things. And I would say that actually IDEs are trying to cope and doing pretty good job here. We once was emailed by a guy called Richard Thompson, who implemented this nice testing suite This is the GitHub where the testing suite is available, and it actually runs the set of test cases on various IDEs to check how they're good or bad at refactoring. So he has hundreds of test cases there covering lots of things like changing signature in various tricky cases for C++, or extracting or inlining macro, whatever. So he actually checked C-Line, Clang Modernize, that is Clang Tidy Modernize, ReSharper C++, Visual Assist, and Visual Studio 2015. And he has some more plans for other tools. And he has all the results logged there in this GitHub repository, so you can just compare and see how the tools are doing. What I love about this guy is that actually after running this test suite in our tools, he actually filled lots of issues in our issue tracker for each case, linking to the GitHub. So he's really cool. But that's very interesting, at least in terms of comparing how the tools are doing with the modern C++ and doing some tricky cases for refactoring. I also have to mention here the Clang rename. The tool is actually quite often mentioned by our users, so that's why I'm actually mentioning it here. And it's a Clang family tool, and it's integrated in many editors for now, but it's just renaming inside one translation unit, so it doesn't cover the whole project. But still, there are interesting things happening with refactoring and Clang for now. There is Xcode 9, who is first time ever implementing a refactoring for C++ on top of Clang. And the guys are not showing the whole code base, but still publishing actually quite a lot of code in the open source. So that's a very interesting time now. And it's interesting to see what they've got. For now they have some just basic things like renaming and extracting. And I'm not sure about the inlining, don't remember. But still that's an interesting thing. Yeah, and it works not on the translation unit, it works on the whole project. And this is actually a cool one. So talking about the unit testing, why I talk about the unit testing here is because you can't do any kind of refactoring or modernizing stuff or changing your code after code analysis without the unit testing. Because if you don't do that, how do you know that you haven't broken actually anything? And we did a kind of a research for the developer ecosystem in the beginning of this year. And we're covering not only our users, but some external users who are not using JetBrains products. And we got some results for C and C++ as well. So there were more than 5,000 respondents. And not a surprise, the Google tests on the first place with 45%. Boost tests coming next with twice less. And then comes all the rest. But that's quite expected, I guess. The Google tests is very widely used for now. And the only maybe issue with them is that you have to download the Google tests and to link them, to compile them properly, so they do not advise you themselves to use the pre-compiled version of the Google test, because you can have problems with settings with which the pre-compiled binary was built, of course. So you have to download the Google tests, you have to build them with your project, with your settings, and then you can use them. But most of the IDEs for now support the Google test out of the box, and that's good. So they provide some built-in test runners or some information to help you with the Google test. But Boost tests are also quite popular for now, and they can be used actually in both ways, header only or linking with the binary. For a big project, I guess it's not recommended to use the header-only way because it increases the build time quite heavily. But still, and others are catching up. So we'll see what unit testing framework will have left in 5 or 10 years. And I actually promised a bonus here. And the bonus here is a package management that we're talking a lot at this conference. And I'm actually, from one side, I'm surprised. From the other side, I'm quite happy. So what's the problem? So we are in C++. And what's the problem with package manager? The problem is that we have one definition rule. So it's not that easy just to use a precompiled binary because we can mess up with the compiler flags and compiler versions. So the usual way how it usually works for us to get a library into a project, you have to find the sources somewhere, and that's usually not a very difficult task, but still, you have to download them, you have to build them, and that could be trickier because who knows what build system the library authors are using for building this library, which scripts they have, which dependencies they have. It's good when you have an instruction provided on a GitHub, like how to build the library, but sometimes like you're spending hours on trying to build the library, getting all the dependencies. And then you have to include this library into your project build. And that's even trickier because you may be building with, for example, a CMake, and the library author is building with something other. And it's good when the library authors are that kind that they are providing special CMake file that's possible. Like even if the library is not built with a CMake, they could provide a special file that you can use to build this library into your project. But what if the build were completely different? So they were using some completely different procedures there. It could be a tricky task. And actually for C++, we have a huge variety of the build system. That's good from the practical point, but that's bad from the point of a package manager. So if we talk about the package manager solutions, there are several different categories here. So it could be language level, or it could be external. It could be a build system agnostic, or it could be built into some particular build systems. It could be a source-based or pre-built binaries, which is impossible just in that way for C++, or it could be combined, which is more reasonable. And it could be system or language specific. And if we talk about the system package managers, the problem here is that there are lots of them, and they're different. And so it's completely impossible for library vendors to pack their libraries for each system manager that's much different from each other. And system managers, they are actually quite often system-wide, but maybe you want a project-wide package manager. So if we try to look for this group and to see what we have, actually, I'm not sure if you all heard about it, but I was very much surprised when I heard that there was a proposal for packaging system in the language. And it was done a year ago by Blizzard. And it's a completely language level packaging system for C++ proposal. So it's providing this kind of using keywords, these manifests for libraries, these options for the packages and all the rest. And there was even a Clang trunk where they started implementation. The original Clang trunk actually didn't get that much attention, but there was a fork from another guy who implemented nearly half of the proposal. So that was quite cool. But still, there are lots of work to be done in this trunk still. So there is no models, no versions supported. So lots of things to be done still. And there was some bright future described in this proposal, like you first starting getting the packages for the CppGet, but then you have a default public repository with all the libraries where everything is just placed, and you just using the language to get the packages and get the libraries in your project. That's a bright future that didn't happen, unfortunately. But from my point of view, that's a good thing that it didn't happen, because I personally don't want a package manager inside the language. We have so many things happening inside the language already that please stay apart with the package manager. If we talk about other options, so there is a Canon, and I guess Diego delivered a bright talk yesterday showing how the Canon works with the whole Artifactory infrastructure that they got from the JFrog. And that's a very nice thing, like the nice package manager. So it's build system agnostic. It has some predefined helpers for CMake still. And so it can work on many platforms. It can cope with several languages. It's not only about C++. There's also Python, Go, and Fortran. And it can download binaries, or it can build from sources. And you can have web repository, or you can have some local repository, for example, set in a company. And so that's a very good tool. And so if you missed the talk from Diego, just catch the recording because he was like showing a very nice workflow, how it all works. There is also Hunter. That's a specific CMake-based package manager. Also like working on several platforms, and it has this nice Hunter Gate like a description that is the whole list of URLs of real packages, and you can just tune it and map some versions to some other URLs, and so that's quite a nice thing that you can play around. And they actually have lots of packages supported, so more than 20, including all the like famous packages like Google Test and Google Mock and Boost and Cache and Android, Alvy and whatever. So this is the different ways of having package manager for now, and I guess we'll have more of that kind, and I really have big hopes for package management, and we'll see how it evolves and which actually solution wins in the end. So that was it about the package manager, and actually that was it about the tools I wanted to talk here. I would like to draw your attention to some references here if you're interested in some particular links. They will be on a slide, so you could catch them up later. And now time for a question. I think we still have 10 minutes. Okay, any questions? Yeah, just come to the mic so that everyone could hear you.
C-line, as I understand, is written in Java. Is there a plan to provide like a C++ implementation, like to boost the speed and performance?
Good question for the booth. Yeah, so it is. So C-line is on top of IntelliJ platform, so it's part of IntelliJ family, and it's written in Java. But you know, we don't see big problems with that. Like, we're doing tools in Java for 17 years already. We're good at that. Believe us. More questions here? Yeah, so we could talk later, so just don't be shy, come. So if you are shy to come to the microphone. Okay, so thank you anyway.